Okay, chapter 10.3 is solving equations with tables and graphs, but it also includes the idea of using algebra. The first equation they give us is 4x plus 2 is equal to 5x. And if we solve this using algebra, which is what we've been practicing so far, we're going to subtract 2 from both sides, which leaves us 4x equals 5x minus 2. Now remember, I can't combine the 5 and a 2. I don't get 3. These are not like terms. But the 4x and the 5x are like terms. So then I can subtract 5x from both sides. That gets rid of that. And now I'm left with negative x, because 4 take away 5 is negative 1. So this is negative x is equal to negative 2. And if negative x is equal to negative 2, then positive x is equal to positive 2. And you can see that, if you don't believe me, you can multiply. Remember, you can do whatever you do to one side, you can do to the other side. You can multiply both sides by a negative 1. And if you multiply both sides by a negative 1 times negative x is positive x. Negative 2 times negative 1 is positive 2. So you can, this is a good trick because they're the same thing, but it's nice to see it in the positive. X is equal to 2. So this is our solution. And what we want to see is, what does that look like when we use a table? Okay, and we're going to use a table. The book does it slightly different. But it's basically an XY table. And we have an X over here. And we have a Y over here. And so we're just going to try some values. Like try 0. What happens when we put in 0? For our equation. And let me rewrite it just so we can see it again. Ooh, I don't like that color. It's too hard to see, I think. 4x plus 2 is equal to 5x. Alright, so if I put 0 in for x, 4 times 0 is 0, plus 2, 0 plus 2, and 5 times 0 is 0. Everywhere there's an x, we're going to put in a 0. And 0 plus 2 is equal to 0. Is this true? This is not true. Okay, so we can see that this is not true. So no. Not true. And let me grab this because I'm going to just redo this a couple of times. Do the little eraser. We can see that that's not true. What if we go back and try a 1? Does 1 work? Well, 4 times 1, if we put 1 in for x, is 4, plus 2, and 5 times 1 is 5. Does 4 plus 2 equal 5? No, that doesn't work either. Go back and we will try with the next number, which is a 2. And of course, it could be any number. We could be using, negative 13 or something, and so it could be tough. But in this case, we already know the answer, so we're going to see what happens as we get closer. You can see that this second one was closer than the first one. Here we got 4 times 2, which is 8, because if we put in 2 for the x, 4 times 2 is 8, plus 2, which is equal to 10, is equal to 5 times 2, and 5 times 2 is 10. And this one works. Yes. So this one works, and we know that x is equal to 2. We try it out with several different numbers. We keep track of the numbers. That's why we use a table, 0, 1, and 2. Keep track of the numbers, and then we can see whether it works. And then the second way is to try using a graph, or the third way. Here's algebra, here's a table, and then we'll try using a graph. And I think I have one of these. I do. Here's my graph. We'll put it down here. And a graph tells us where the line, or where it's true and where it crosses. So okay, so we're going to take the two sides of our equations, and they're equal to each other. 4x, oops, I guess I need something. There we go. 4x plus 2 is equal to 5x. So these are equal to each other. Whenever we're graphing in two directions, we have an x here, and we have a y in this direction. So our horizontal is x and our vertical is y. And you remember how to plot points. Well, what we're going to do is we're going to take 5x and we're going to set it equal to y. So we'll say y is equal to 5x. And we're going to take 4x plus 2 and we're going to set it equal to y too. So y is equal to 4x plus 2. Now, if this is equal to this, if 4x plus 2 is equal to 5x, then, and y is equal to 5x, then y is also equal to 4x plus 2. And the reason we use the y is because it allows us to put it in a two-dimensional linear coordinate graph, and this is going to work really nicely. And we're going to use our table again, just like we did before. This time it's a little easier, and we'll use a table again over here. And we're just going to see what we get. And I'll show you. Here's the x, and here's the y. This is the part that's going to take us some time to learn, unless you've done this before. If I put a number in for x, I put in, say, 0. 5 times 0 is 0, so y is equal to 0. So if x is equal to 0, then y is equal to 0. Put in another number for x, 5 is equal to 1. If 5 is equal to 1, or if x is equal to 1, then 5 times 1 is 5, so y is equal to 5. Does that make sense? 5 times 1 is 5, so y is equal to 5. If x is 2, 5 times 2 is 10, so y is equal to 10. And if we were to take these points, they become points like this, 0, 0, 1, 5, and 2, 0, and we plot them. The first one, 0, 0, is right here at the origin. The second point, 1, 5, is over 1 and up 1, 2, 3, 4, 5, right here. And the third one is over 2. Oop, that's not supposed to say 0, that's supposed to say 10, because this says 10. Okay, sorry, that was a little mistake. Over 2 and up 10, and that puts us somewhere up in here. And my graph doesn't include enough places here, but we're going to go ahead and draw a line like that. Does that make sense? And then we're going to see that our other graph is going to look similar. X, I'm going to have to get rid of this just so we can use the space, and y. Oops, I'm still on the linear one. X and y. Okay, so here we're going to do the same thing, 0, 1, and 2. And we're going to see what happens. 4 times 0 is 0 plus 2. 0 plus 2 is 2. So y is equal to 2, because if x is 0, well, that's what we get. If we put in a 1 for x, 1 times 4 is 4, plus 2 is 6. So we get that point. If we put in a 2 for x, 4 times 2 is 8, plus 2 is 10. And I think you might notice that we get the same answer with 2 for both equations, which we should. It should work that way. Let me go ahead and switch to green now. Okay, so now when we put these in, this is 0, 2, this is 1, 6, and this is 2, 10. 0, 2 is right here. Starts at 0, goes up 2. 1, 6 is over 1, up 6, which is right here. And 2, 10 is over 2, up 10, which should be the same point as we have here. And then we take our line, and they cross. Oh, I missed. I'm going to go back and try that again. This is the hardest part, is to get your line without a ruler. That didn't work either. If I just start here and go to here, then it looks almost like they're the same line. The point is that the solution to the two equations, the solution is the point that they cross. The solution is 2, 10. Okay, and the x value that we came up with over here, x is equal to 2. And that's what the x here is, because this is x and this is y. All right? Okay, so we've done a bunch of stuff. The book tells you to use a graphing calculator, but we don't have those. So we're going to solve not using algebra, which you've practiced at. Okay, let's try this again. This is negative x equals 2x minus 3. All right, so this makes a little more sense. And the graph, again, you can do it any way you want, but this is the way the book shows. We want to see what it's equal to. So x is here, and the solution, oops, the solution is here. If we go back to the algebra method, negative x is equal to 2x minus 3. And I want to get everything together, so if I add x to both sides, this goes to 0, and this goes to 3x minus 3. And then this looks a little funny, so I'm going to add 3 to both sides. So 3 equals 3x. Negative 3 plus 3 cancels out. 0 plus 3 is 3. And then I'm going to divide both sides by 3. 3 over 3 is equal to 1. So x times 1 is equal to 1. And we don't have to write that 1, it's just x. Okay, so we see the solution, x is equal to 1. But our equation is going to go here. We're going to just try with 0 like we did before. This is negative 0, which is kind of an oxymoron. I don't think we can really do that, but 2 times 0 minus 3. And 0 is not equal to 0 minus 3. Negative 0 is the same as 0, is not equal to 0 minus 3, so no. Okay, if we try the next one, which would be 1, negative 1, because x is 1, is equal to 2 times 1 minus 3. And we can see that negative 1 is equal to 2 minus 3 because negative 1, 2 minus 3 is negative 1. So yes, that's our solution right there. Okay, good job. If we want to do the same thing with the graph, we'll see if we can make this work. Okay, negative x is equal to 2x minus 3. That's our equation, and we're going to let y equals both sides. Y is equal to negative x, and y is equal to 2x minus 3. And then I set up our little tables, and you use an x and a y. And then you put in numbers like 0, 1, and 2. If x is 0, then y is 0, because negative 0 is still the same thing. If x is 1, then y is negative 1, and if x is 2, then y is negative 2. Over here, if x is 0, 2 times 0 minus 3 would be negative 3. If x was 1, 2 times 1 is 2 minus 3, and that's negative 1. And then if x were 2, that's 4 minus 3 is positive 1. You can see that we do have one that matches. This is kind of our table. But then we have to put them on the board. So let me grab another color. And then we'll do that. This is 0, 0. 1, negative 1, which is down here. And 2, negative 2. Which is this last point, 2, negative 2, and we can draw this line like that. And then the next one over here is 0, negative 3, which is right here, 1, negative 1, which is right here, and 2, 1, which is right here. And these cross, right, like, oops, I can do this. Right, like that, and they cross at this point. And this point right here is 1, negative 1, and that's our solution. So that x is equal to negative 1. Y, x is equal to positive 1, y is equal to negative 1. X is positive 1, y is negative 1. Okay, this is a tough lesson. You guys got it.